Good afternoon, everybody, and welcome to today's MySQL webinar, New MySQL 5.6 RC Features. My name is Kevin Askew. I'm Director of Sales here at TechExtend. I want to run you through our brief agenda before turning it over to Lee Stigile from MySQL to run today's webinar. So TechExtend is a value-added provider of infrastructure and developer software, systems, and services. Previously known as Programmer's Paradise, we have over 25 years of serving technology professionals in enterprises of all sizes, from small and medium business to Fortune 1000, federal and local government, and lower and higher education. Our 30-year history as Programmer's Paradise started off with software developer and database tools. Now as TechExtend, we also focus on virtualization and cloud computing, storage and data management, business intelligence and information management, and mobile device management. Under our database worldview, we include industry-leading database tools for your end-to-end database infrastructure needs. I will now turn things over to Lee to start today's webinar. Lee?
All right, thank you. So MySQL just introduced some very powerful new features with their 5.6 release candidate. So in the next 45 minutes, I hope to show you how you can leverage those tools for your next project. A little bit about myself. So I'm Lee Stigile, and I'm the Sales Consulting Manager for the Americas. I've been with MySQL for 7 years, which means I was with MySQL as an independent company, and then when it was part of Sun Microsystems, and now as part of Oracle. I hope to add some of that perspective as we talk about some of the new features. First, I'm going to start off with just a little bit about how MySQL fits into Oracle's strategy. Then we'll get into those features. Then we'll talk a little bit about if your database is mission critical, what you can get with our Enterprise Edition to help you save some time and money and also reduce risk using our tools and our monitoring and our support. And then we're going to do a quick demo of our Enterprise Monitor and close up with a word on our Premier Support. One of the questions I get a lot is, why did MySQL or why is Oracle interested in MySQL? In January of 2010, Oracle bought Sun Microsystems, and with Sun came MySQL. But what a lot of people didn't know was that actually in 2005, Oracle bought Innobase, and that was the main engineering team doing development on the MySQL transactional engine, our key underlying engine that really powered MySQL. And so for 7 years, Oracle has been involved with MySQL. And so why is Oracle making this investment? Well, on the slide here, you can see that Oracle is looking at a complete solution from your application all the way down to storage. And they want all the products to be integrated and to work together, to be tested together, and to all provide the same level of support. And they want best of breed at every level, but also across industries. Now with MySQL, we're the #1 online database. And if you look at 7 of the top 10 web properties, those are all running on MySQL. Facebook, Twitter, YouTube, those are database-driven websites, and those are powered by MySQL. So that's an area where MySQL is the #1, the best of breed in that sort of application level. And Oracle has an interest in having that and having MySQL and the hardware and the software and the storage all integrated and working together. So for MySQL, Oracle is focused on using MySQL as a solution for web, mobile, and embedded properties. I've talked a little bit about some of those companies, but here's a few more. So the web and the enterprise are most common in the left box. But because MySQL is lightweight, runs on many operating systems, and is very easy to use, it's a natural fit to be embedded with a lot of products. So F5 management tools, Sage CRM, simply accounting, Cisco products, eClinicalWorks in the healthcare space, they all distribute products that include MySQL with them. Along the bottom tier are cloud hosting companies, just a few of those out on the market. And for all of these companies, the default database is really MySQL. A key message I want people to take away from this session is to see that Oracle is investing heavily in MySQL and it's driving MySQL innovation. And the result of that is that we're delivering more and better products. We have more engineers working on MySQL now than we've had at any time, whether it was MySQL as an independent company or part of Sun Microsystems. This is our release history from 2010, when the acquisition took place, to current. You can see in 2010 there are two big releases on there, our MySQL cluster 7.1 and then our MySQL database 5.5. Our customers have told us that 5.5 is the best release that MySQL ever had, both in quality and also the number of features included in the product. A big reason for our ability to release 5.5 so quickly was that Oracle united the NODB team with the rest of the engineering team, and we got a lot of synergy from having our engineering teams working together. 2011, we put a lot of work into integrating MySQL into other Oracle products. So there's Oracle certifications with Golden Gate. We created a template for Oracle VM, Oracle Virtual Machine, which is the Xen hypervisor that Oracle supports. And it provides a very nice solution for MySQL in a virtualized environment, a cloud type environment, and gives us some high availability options as well. And then in 2011, we introduced our Authentication plugin and our Thread Pool plugin that I'll talk about during the enterprise section. 2012, that's where we're at now. So we released GA Cluster 7.2. We've just announced a beta version of MySQL Cluster 7.3. And then what we're mainly here to talk about is MySQL Database 5.6 RC. Now, RC is a release candidate, which means we think this is the candidate, the feature set that's going to go GA. So this is our last release before the GA. I thought it was appropriate to talk a little bit as an introduction to what people said about our 5.6 when they went to our MySQL Connect conference. And that conference was right before Oracle Open World. And these are some tweets that came out of the conference. So one is replication, global IDs, crash safe, multi-threading, GID is huge, makes spillover easy, missing transactions on slaves easier. The next one is online DDL in MySQL. Makes me want to go up to the RC right now. And then finally, okay, performance schema in 5.6 is totally cool, and we're going to talk about why those features are cool and what they mean. So there's a lot of features in 5.6 and a lot go into some real detail. I thought maybe the best way to do it is to select the top 5. And this is based on just feedback I've gotten and feedback we've gotten from our community. So the biggest challenge people have with MySQL right now is online operations. So with 5.5 and prior, if you wanted to add an index, if you wanted to add a table, underneath the covers, MySQL would essentially recreate the entire table. And because of that, it would give you a locking error. So you'd have to do it offline. And people worked around this in many different ways. So there's one script out there where you could set up replication, and you'd make the change on a master, and then you'd switch over to a slave and make the change there, and you'd switch your production database as you go from, so you don't have any offline time. But now in 5.6, we have online DDL for NODB tables. So there are other operations here that you can do online, these are the most common: add index, drop column, add column, rename column. The typical scenario is you have an application like on the screen there. I just took a screenshot of a shopping cart application. So if you take that offline, that's when people cannot make orders. That's going to cost your business. But let's say that you have a performance issue. You just saw that the developer added a new query, and that query doesn't have an index built on it. What you can do in 5.6 is now online you can build that query, and you don't have to take it offline. The number 2 item I listed here was just general performance. It's always great if you can install a new version of a software product and you get a considerable performance benefit just out of the box. Many of our customers reported that going from 5.1 to 5.5, and you're going to see that again going from 5.5 to 5.6. So if you're on an older version, 5.0, 5.1, you're going to see considerable performance improvement going to 5.5. To give you a little perspective, going back to 2008 with our version 5.0, we could really only utilize, this says 4 CPU on the graph, but really we're talking 4 cores. And in 2008, that wasn't a huge deal. But then 2009, 2010 came along. That was a big problem. And even in the initial release of 5.1, we weren't scaling very well, much beyond 4 to 8 cores. Midpoint of 5.1, we added what we call the NoDB plugin. You could put a special version of plugin, and that would scale up to 16 cores. It really wasn't until 5.0 or 5.5 though, where out of the box you could get scaling where we would take advantage of your hardware. And we continue to make improvements, so 48 cores with MySQL 5.6. We're going to take advantage of that, and we're going to scale and use your hardware effectively. Now this slide is just a story about utilizing the processor, but we're doing the same thing utilizing your memory and also faster drives, flash and SSD drives. We've added more threads and made them configurable so we can take advantage of the background operations, and a lot of the things that are writing to disk, now we can configure that to do those writes more quickly to take advantage of faster disks. Just a couple of benchmarks. This is a read-write benchmark, 32 core. We use the same hardware for 5.5, 5.6. We did optimal tuning for both, so we didn't, we didn't intentionally try to handicap one version against the other. And there you can see, considerable improvement with 5.6 out of the box. The next graphic is for read-only. So now I present read-only because there's still a perception out there that you want to use MyISAM if you're really looking for very fast read-only performance. But we are investing heavily in NoDB to make sure that you can you can move all your applications over to NoDB and you can get the transactional performance plus the high read. So those are just some examples. When talking about performance, it's a little hard to go into everything because a lot of them are very detailed, very low-level issues. So here is just a list of some of the things that are fixed. They split the kernel mutex, separate threads for flushing operation, multi-threaded purge, reduced the buffer pool contention, new adaptive hashing algorithm. I did put on the bottom there, so there are improvements for just MySQL in general. They went to a different memory allocator, one that deals with thread concurrency better. And then they addressed some locks and contention just with opening tables because there was a big contention issue just when MySQL went to open tables. So focus on NoDB and MySQL, big performance improvements. Sort of on a related note, is the MySQL optimizer. I say related because it's performance related. So the optimizer is the part of the code in MySQL where it addresses how indexes are used, and if you execute a query, in what order. So if you have a customers table and an orders table, it sees which one has fewer rows and it starts with that one. It also, we have a cost-based optimizer. So whenever we decide how to do something, we look at the costs of the different paths and then we go with the lowest cost path. All of that logic is in the optimizer. Again, it's a feature that can get very technical and very specific. So I thought maybe the best way to tell the story was to talk about the benchmark we used and why we used it and what improvements were made. So we use DBT benchmarks, and that's a corollary to TPC. It's an open source variety of TPC. And there are several different versions. So we did DBT 3, but there's also a 1, 2, 4, and 5. Now the other benchmarks, MySQL has always historically done extremely well on those benchmarks. It's been for OLTP, web services, things that MySQL is just naturally good at. But the DBT3, that's one where we've struggled historically. So this was large data volumes, complex queries, and it's the benchmark is labeled for decision support systems. Query 16 that you see on your screen there is a good example. Now, I've actually seen, much deeper queries, but this is an example of complexity in that it has a subquery, which usually if you call our support team and you say, hey, I'm having troubles with this query, and they see a subquery, their first advice is to, well, let's rewrite that into a join. Well, that's not necessary anymore with 5.6. The other thing you can see, there's an in clause here and a group by and an order by query. So this is where our focus is to expand out so that MySQL is performing better in different use cases than just the typical very short, simple, quick queries for web operations. One of the solutions is materialized subqueries. And query 17 here is a good example of that. If you look at that select statement, it really only has to run once. And query 17 is a good example because we actually did really horribly on executing this query. We don't know for sure because nobody would actually run it for this long, but we estimate that it would take 40 days to run this query. Looking at this, the solution is actually, well, I should first point out with 5.6, it went from 40 days to 6.8 seconds. And it's a fairly logical solution here. That subquery really should only run once and get stored in memory. Instead, MySQL is executing it over 1 million times for each order key that it found for comparison purposes. So it executes it once, it creates a hash index, puts it in memory, and this is a materialized subquery. You'll also see a feature out there called postpone materialized subqueries. It's some logic, so if we see that there's no order keys even selected from the primary table, then don't even run the subquery. Or if you're doing an explain statement, just estimate how long it's going to take and don't actually execute that subquery. Another example where we've made some improvements, we call this features BKA and MRR, that's batch key and multi-range read. And again, I think it's important to look at the focus. So this is for disk-bound queries. So this goes back to really large queries where your data is not going to fit in RAM and trying to improve MySQL performance on that type of query. 5.5 and earlier would do index nested loops. So if you were joining a customer in order table, we'd get the first customer, look it up at the key, go find the order key, and then we grab the data from the table. That caused a lot of communication, a lot of loops, but it also caused random reads from disk because we'd be going from key order and then looking it up on disk, which makes sense if you're in memory. but if your data is not going to fill the buffer pool, then that's a challenge. So what this does is it actually looks at the customer table, gets all the keys in a batch, as the name implies, sends that down to the storage engine, and then the storage engine matches those to the order index, and then it sorts it actually in table order, in natural order, and it sweeps the table and does a table scan so that it can get that data sequentially. I think the big thing here is, this makes sense for the right type of queries. If it's a smaller OLTP application, then the extra sorting is going to add overhead. But in a case where it's actually a larger data set that's on disk in a complex query, then this is going to be much faster. And in fact, if you look at the benchmark results for the queries where they actually did a join where it applied, in most of the case, it was a substantial performance improvement. So the orange bar here shows that the query executed much more quickly. There is exceptions here. So query 17, the way the data was distributed on disk, made it so it didn't benefit from this. And so this is a dynamic, something you can set dynamically. It's turned off by default, but you can enable it dynamically if you're looking at a use case like this. So there are many, many more optimizations that were made by our optimization team. And this is another case where, Oracle has made a big investment in engineering and it's paying big dividends. I want you to see, though, that we're looking at trying to optimize MySQL for more use cases, make it easier for our developers so we're not changing subqueries to joins. We are focusing, we're optimizing it so you can do many tables in a join, performing improvement, and then just general improvements is going to benefit everyone. We've optimized if you're using the limit clause, which is very common in web properties where you're doing paging, you just want to show the top 5 and then the next 5. We've optimized those statements, index condition push down, where we can resolve it just based off the index alone, and we don't have to go to the data to get some of that. So some big improvements with our optimizer. So this brings us to number 4, the performance schema. MySQL has always been extremely lightweight and fast and simple, easy to use, easy to install. But one of the things we've never really invested in is with a lot of the instrumentation internally that will tell you exactly where MySQL is at in the code when it's parsing something. Or if you're running a query, is the bottleneck at the processor or is it the file? Those are the type of questions that we've never had the tools, the implementation internally. So you want to know, which queries are most resource intensive, which tables and index have the most concurrency, the most load, what users are consuming the most resources, see what your network load is. And then we had those basics in 5.5, but 5.6 really does aggregated statistics by thread, user, host, and object, so that you can get summaries and actually put those statistics to good use. Now, there's a lot of details in setting this up, but I want to emphasize that you turn it on, you enable it via your config file, and then you have very fine-grained control on what you can enable, and you can do it all dynamically. So you can enable different instruments, and you can enable whether you select just the count, so you're storing the time, and also how much data you can store. So it's very sophisticated, very flexible, and it also gives you the ability to collect all these statistics and then turn them off so you can do sampling and not have to worry about the performance implications. So it's not like turning on the slow query log and just waiting. It's something where you can get these very quickly. So let me give you examples on what you can get from our performance schema. So you can get the slowest queries, the most common queries, all of these things, it's going to be much faster than you can get from a slow query log. It puts it in a table, and so you can query that, you can group it, much more flexible type solution. It also gives you like real-time insight, what queries are running right now. Like this is just showing, you can get the last 10 statements. Now here's where it really gets interesting. So this is something, we've never been able to get at, even if you had the slow query log. So files by file I/O. So you can see the read count, the bytes in, the bytes out. And if you just look at this, you can see IB data, MySQL SLAP is the utility that's running, and T1 is the file, has the most contention, your log files. And then I think this is very useful. So we've had variables before that said you were using temporary tables, but we never really had a variable that told you which temporary tables, what statements were causing those temporary tables. This is something you can now get at with the performance schema. All right, last but not least is number 5, which is replication. 90% of MySQL customers use replication. It's very easy, it's simple, it's great for failover, for a backup. But if you've ever used replication, you know the pain points, which are typically your slave server can lag. So the master server is multi-threaded, but the slave, to make sure that your updates get applied in the right order, has always been single-threaded. So there'd be one thread picking up the updates, applying them to the slave server, and then another thread picks them up and applies them serially on your slave server. The other pain point is crash recovery. So if you crash and then you start back up, you're probably used to getting errors that say, it's trying to repeat a duplicate key error because it's trying to repeat an insert that it already got from the master. So multi-threaded slaves is the first feature. So what this adds is one thread. Well, how it works with 5.5 and prior is that it's one thread per instance. What we've added with 5.6 is you'll get one thread per schema. So if you have multiple databases or schemas all within one instance, each of those schemas can use a thread. Now, of course, the next step that we're working on, and some of the features I'll talk about in a moment, are adding multiple threads per schema. But right now, this is very useful, especially if you have a multi-tenant type architecture where you have maybe several customers that you're hosting and you put them each in their own database, but in a single MySQL instance, can give you some big performance improvement. On the performance side, we also made an improvement to the binary logging, which is the main overhead that you would have when enabling MySQL replication as you turn on the binary log. Well, we have a successful implementation of group commit so that similar transactions all at the same time can be committed in one single commit. And in one test we did, our engineers reported that 5.6 with the bin log turned on was faster than 5.5 with the bin log turned off. So that goes to this feature, just very effective bin log commits, but it also goes to just general performance improvements with 5.6. With replication, one of the interesting things is you would apply your data to a transactional database, NoDB, and this would be a transaction, it would be an atomic transaction. But on both the master and slave, we had files that would keep track of where you're at in the replication, like what position in the bin log you're at, and those would actually be kept in text files. So while your data application is transactional, atomic, there would be a separate write to this text file saying, okay, we just got to this position in the bin log, but that's on a text file. In 5.5, we added some updates where you could force a sync of those text files to disk, which helped. But really the real solution is what we've added in 5.6, in that now the position information is all transactional. So when you commit a transaction, it's committing your data, but it's also committing that position. And we call this crash-safe slaves. So now when a slave crashes, you shouldn't get these instances where it starts up and it tries to start in the wrong spot and it doesn't automatically start up. A similar type of feature is the global transaction identifier. So now all slaves in a replication chain, each transaction has a unique identifier. That will help us know if the update has actually been applied to the slave. So we shouldn't have these cases anymore where we have to go through the bin log and try to figure out which updates have hit a slave server. It also leads us to some additional great functionality. So, in combination with a crash-safe slave, now the master-master scenarios make more sense. And then we can also automate failover now because we can have tools that can verify, okay, did this transaction ID get applied to the slave? And that's easy to check. And in fact, that's what we've released. If you download our Workbench, there are utilities within Workbench. There's two, REPL admin and REPL failover, which will automate failover. The admin one is where if you just want to promote a slave, it will show you all your servers that are replicating, and you can just identify a slave and it will automatically stop the master, check to make sure updates have hit the slave, promote that slave to a master, and then point all the slaves to it. And then the REPL failover is designed to do that automatically. So that is my top 5 features for the 5.6 release candidate. I should mention just a couple more. We do have full text search, which is now part of NODB. I should say full text search indexes. So very fast searches. Also on NODB, we also implemented portable table spaces. So if you need to move your database server to another server, you don't have to dump. You can actually just export your database to a file, and it keeps it in binary form, so you're not dumping it out to a text file and trying to reload it. Those are great features. And then just a lot of small features, so millisecond support is now in the server. Shifting gears here, the MySQL Enterprise Edition, everything we've talked about so far talks about kind of the middle core here, labeled MySQL with the database server. And that is available in a commercial version, whether you have an enterprise subscription or not. Around the outside, we've tried to add tools to help with your investment. So if your database becomes mission critical, we have auditing for security. We have some authentication tools for security, online backup, high availability options, monitoring tools. Again, trying to save time and money and also reduce risk. And so let me go through just a few of those. And first, we'll start off kind of on the security side. We always see headlines about websites getting hacked, but if you look at the actual statistics, most of your security breaches are internal breaches where existing employees, someone gets into systems that they're not supposed to. Sarbanes-Oxley, PCI compliance, a lot of these all require some sort of audit flow trail. And with our MySQL Enterprise subscription, there's a plugin that you can load up in your config file that will create an audit trail. Now there's a lot of different options on, you can put this in a buffer depending on how much RAM, and then you can set how often it flushes to disk to ensure that there's not too much overhead with this system. And you can track who makes changes and when they made it to anything within the database. On a similar note, we have external authentication, and this is really single sign-on. And it's also required by a lot of like Sarbanes-Oxley, PCI compliance, in that if you have a DBA that quits, you don't want to have to go to 20 MySQL servers and make sure their account is removed. Instead, you can have it so MySQL authenticates to LDAP or Active Directory one single source for authentication, and it helps manage things from a security standpoint. On the scaling aspect, I think this graph says it all. So we have a thread pooling that you can also enable, and this is most useful if you have 200 to 300 simultaneous connections. Now, this is not connection pooling between your application and the server. This is thread pooling internally between the server and the threads going to the processor. And what this does is it manages those threads in groups to make sure that it's used effectively by the processor. And as you can see from the graph, you're not going to run into issues with the concurrency going on that you can maintain that performance. We offer, again with the MySQL Enterprise subscription, an online backup. And this is a binary backup, so it's not dumping this to a text file. It's doing a hot online backup of NODB. A lot of options, so you can do partial backups, incremental point-in-time recovery. You can stream it to another server. And I think really the critical part of this type of backup option is the recovery time. So it's 20 times faster than recovering from MySQL dump. And the other thing is that it is developed by our NODB engineers. You don't want to take risks with your backup files, because if your system goes down and you can't restore those files, that's a huge issue. So there are some other products out there that are reversed engineered of this enterprise backup, but there's also reported issues of people not being able to restore from those backups. So this isn't a case where you want to cut corners, and we definitely recommend MySQL Enterprise Backup for all your online backup. Included at the enterprise level are high availability option, and I'm just going to quickly mention 3 of those. One is an active passive failover, which we call DRBD, which is supported for Linux customers. It does synchronous block writes between 2 servers, essentially mirroring the hard drive at 2 servers. It's managed at the Linux kernel level, and then we use some scripts on top of that to handle the failover and switch over to the second MySQL instance. And you can usually do that in about a minute. And the nice thing is that your database is consistent and it's on 2 physical servers. A similar implementation with shared storage for Windows. We have native clustering, Windows clustering. You can set that up and use it with MySQL. So the Windows clustering server with Windows Server 2008 R2 and then Windows Server 2008 both support clustering, and you can set this up and take advantage of your existing architecture. And we've just added support also with Oracle Solaris cluster. So if you have a SAN or with individual servers, you can set this up, and again, it's an active, passive, great high availability, can switch over fairly quickly and gives you a good implementation here. Now, to try some of these things out, one tool that's available for everyone, and it's available on our website, is the MySQL Workbench. And if you haven't looked at it lately, I encourage you to do so because we've made some great improvements with it. One of the newest features is the database migration wizard. If you have some SQL Server databases, Postgres, Sybase, we can connect up and migrate those over to MySQL. So if you're wondering how MySQL would do with a certain application, it's easy to try out. This is also our main tool for ER diagramming and doing graphical development. With that, let me take just a moment, and I want to show you our MySQL Enterprise Monitor, which is probably our best tool for really maintaining your database here. So it'll take me just a moment to share out my application. Okay, on the screen I have the MySQL Enterprise Monitor. Just make an entry in the chat if you're not seeing it so we can know there, but otherwise I'm going to assume everyone can see this okay. When we went to develop the monitor, we went to our customers and we asked them, okay, so there's other generic monitoring tools out there. Where do they fall short? What could you use for MySQL? And they said, we need something that will monitor all our MySQL instances. Most people have, several instances, if not 20 to even 100, 200 MySQL instances all running. And they need to be able to look at them all. And not only do they have many, but they're linked together with replication. The other thing our customers told us is they want to have a single glance to know whether there's issues. And then the third thing, which is probably the biggest, is they want some advice. So there's a lot of monitoring tools that say, hey, there's a problem, but they don't tell you how to fix it. And what we've tried to implement is something that'll tell you there's a problem, hopefully tell you proactively that there's a configuration change you can make to optimize your system. We talked to a number of MySQL users who have multiple hats. So they're the application developer, they're the architect, and they really want to spend as little time configuring and monitoring MySQL as possible. This is not where they see their expertise. And so this monitor tool is great because it makes sure your systems are configured properly, that they're installed securely, and then you can focus your time on other jobs. On our main screen here is the dashboard. If you look to the left, I have 4 servers, but you can also put those in groups. More towards the middle here is the graph, the graphing operation, and there's 20 graphs. And then over to the right, this is what we call our heat chart. And the heat chart is kind of that single glance that tells you if your servers are up or not. And I can drill down into any single server, and it will give me the details of that server. So here I can see the version of MySQL, and I can see what it's running and the hard drives and the amount of free disk space. If I look over here on the heat chart on the right, notice under critical alerts. If I select critical alerts, I can see that there are 4. And I can see here that there were 4 issues, and this is a good example. I'm going to select the last one here is the table cache set too low for startup. Now this is something where we monitored the server, we saw there was an issue, and we gave this advice proactively, letting you know that we would change this configuration. And these are rule of thumbs put together by our engineers on how to best tune your system. And I think the best thing we have here is it says exactly right here what you need to do, what your parameter is, and where you should set it. And we also reference your config file up here. I'm going to switch over here to the Advisors tab. So the Advisors tab lists out everything we monitor. And we have administration, backup, memory, performance. If I look under administration, again, this goes to telling you how your system should be set up and making sure it's set up correctly. Here's one where I think most DBAs would miss this, NODB transaction logs not sized correctly. We go with a rule of thumb, and we give you a lot of details, including the actual formula we're used to configure this. And a quick note, here is also backup. So we tell you if the backups are done, if they need to be done, if it was done successfully. And probably the most popular are under performance here. So people a lot of times configure their database well from day one, but then a year later, the way your website is being used is different, and you need to do a little different tuning, and a tool like this is going to help you keep up with that. I want to switch over to the Query Analyzer. So this is the Query Analyzer, and if I go down here to the bottom, you can see where it tracks the queries going through the system, and it tells me how many of these queries have executed, how many rows were read, how many bytes were read. There's an indicator right here if it's doing full table scans, which indicates that it's not using indexes. And I can highlight a query, and it'll give me details, show me the full query. And I just wanted to go here to the example explain. So this is the most interesting part in that it actually gives me the source location where that query came from. Now this is enabled through our Java connector where you can send the queries directly to this interface. And here you can see that my application is actually MySQL LoadGen, and on line 138 it generated this query. This is great if you have a troublesome query that your developers put in your system and it's wreaking havoc on your database. You can go back, track it down, find out where it is, and also there's an explain plan here where it'll tell you what indexes are being used and how it's being processed on your system. A quick look at graphs, and one thing I didn't point out prior is that all the graphs, so here's disk I/O usage, but we also have CPU connections. All these graphs get correlated so that you can select an area of the graph and it will correlate to SQL statements that are going through the system. So if you see a peak, you can select that peak area and CPU spike, and you can see which SQL statements are creating that spike. All of this is included with a subscription which comes with your MySQL Support. And just a word about our support is we really encourage people to use support proactively. Again, it's all about reducing risk and saving time for your DBAs. And the MySQL Enterprise Monitor is actually linked in so you can see your support issues. You can also download files and upload it to our support team. So it's a very good overall solution, all integrated together. So we covered the top 5 features with 5.6. We also talked about key tools, including auditing, authentication, backup, monitoring, thread pooling, and support. If you would like to try any of these out, here are our links. So mysql.com. We also have a dev.mysql.com where you can get downloads and documentation, and our forums, Planet MySQL, which is our blog aggregator. And all of our products are available that you can try, including our enterprise products. So MySQL Enterprise Backup, if you want to try the commercial version with thread pooling. And you can get those from edelivery.oracle.com, or you can go to mysql.com and go /trials. So that concludes our presentation. And I think with that, I'll ask Danielle to come on and we'll take a look at any questions that came through.
Okay, we don't have any questions as of yet. Please, anybody who has a question, feel free to type them in the chat or in the Q&A. And while we're waiting for some questions to come through, let's see, anybody has any questions?
I did have a question that came through on the chat channel. It was someone that was stuck on 5.1.42 and cannot upgrade to 5.5 due to a partitioning bug. Right. Now, I don't know what that bug was specifically, but I do know that 5.6 made a lot of enhancements to the partitioning, including the number of partitions you can use and also how locking is handled, as well as a lot of bug fixes. So I would take a look at, if you know the specific bug, go to bugs.mysql.com or take a look at our 5.6 release notes, because I do suspect that it was probably most likely addressed in our 5.6 release.
Okay, another question that came in is, when is 5.6 expected to be released?
So with a release candidate, we're kind of just waiting on feedback from the community and the number of people that are going to try it. So typically it releases within 90 days of your last release candidate, but it's all going to vary upon the feedback we're doing and what has to be internally done. So I guess all I can say is it should be very soon, but it all kind of depends on where we're at with last-minute bug fixes.
Okay. Another question is, are the improvements in performance just INNODB related, or will ISAM improve as well? I'm just wondering if it's time for us to move to INNODB.
The bulk of the improvements are on NODB. There are some improvements to MySQL, both on just how the lock contention and the memory allocators. Our goal is to make NODB more accessible for everyone by improving the read throughput, also adding the full text search, and then also making the table space transportable. So we do encourage people to move to NODB as soon as possible. We are still making some updates to MyISAM, like now you can have multiple key caches, and we fix some contention issues with that. And there's also some issues at the higher level at MySQL that are going to have some improvements.
Okay, looks like those are all the questions for now. If anybody has any further questions, just feel free to contact us. And with that, I'm going to turn it back over to Kevin.
All right, thank you, Danielle, and thank you, Lee, for today's webinar. Thank you, everybody else, for attending as well. To contact us by email, please do at info@techextend.com, or by phone in the U.S. at 800-221-7710, or in Canada, 888-423-2700. That concludes today's webinar, and again, thank you, everybody, for attending, and have a great day.